Hi everyone, welcome to Ethics, Analytics, and the Duty of Care. We're in Module 7, the decisions we make, and this is the first of 4 videos in which I'm going to be looking at data. I'm splitting it into 4 videos so that we don't have this big, huge monster video, so I hope you appreciate that. It does mean that we have 4 shorter videos, which would add up to a big, huge monster video. Nonetheless, decided that I'd like to break things up a little bit. Basically what we're going to look at is how to source data or where the sources of data can be found, decisions that we make there, then looking at things like classifying data, managing data, and working with data. So, without further ado, let's begin. First of all, I guess it's kind of obvious to most people what data is, but for the purpose of completeness, let's state the definition to be clear about it. I've just taken the definition from the first result on Google when I typed in "what is data," and we get it as a noun, facts and statistics collected together for reference or analysis. Or similarly, the quantities, characters, or symbols on which operations are performed by a computer, being stored and transmitted in the form of electrical signals and recording on magnetic, optical, or mechanical recording media. And it could be recorded in other kinds of media as well, but those are the big 3 right now in the year 2021. In philosophy, there's the concept of data, things known or assumed as facts, making the basis of reasoning or calculation. You kind of get the idea, right? I mean, data is the input to our analytics or AI systems. It's probably going to have to be digital in some way, although it could be a digitization of some external source. And it's going to be taken as a given. We would think of it as the premise of an inference or the raw material or something like that. So similar terms include facts, figures, statistics, details, particulars, specifics, features. We often think data needs to be numerical or mathematical, but we know that that's not true. It could be qualitative data as well as quantitative data. It could be descriptions, accounts, pictures, so on. So, there's a wide range of different types of data, different sources of data, all of which becomes the raw material for our system. Since we're looking at AI and analytics, we're not so worried about the philosophical sense of data, although, it always lingers in the background. But we're thinking specifically of data for computation. So here from Jack Vaughan, we'll use the following accounts. I won't say definitions because that's too strong, but data is information that has been translated into a form that is efficient for movement or processing. Now we need to be a bit careful about that because information is a technical term. Data can provide information, but not all data provides information. I'll give you an example. Suppose I know that Andrea's shirt is red. Okay, I already know this. So if you came to me and said, Andrea's shirt is red, there's no information there because you haven't added to my stock of knowledge about the world. Or another way of putting it, you haven't reduced the number of possible states of affairs the world could be in. But you have given me data. And I might maybe add it to my previous assertion or whatever. Certainly I'd need to go through some sort of data processing in order to understand what it was that you were saying, etc. So data is the presentation of the content, if you will, but it doesn't by that fact acquire semantical importance. It might be information or it might not. It might be knowledge or it might not. It might be wisdom or it might not. So it's just the presentation. Similarly, when Vaughan says data is information converted into binary digital form, no, not information. I think a better word is content. I don't know what other better word would be, to be quite honest. Measurements, perhaps, readings or readouts, creative output. There's a range of things it could be. If we look at the little diagram there, we get a sense of the sorts of things data could be, like quantities, information, graphs, measurement, observations, facts, numbers, and I could go on, right? Videos, speeches, weather reports, there's a whole range of things that can be data. And that's part of the problem. Almost anything can be data. This video is data, and within this video, one segment of it, say beginning now and ending now, that's also data. Vaughan also uses the term raw data to describe data in its most basic digital format. The only type of digital format there is other than basic is analog, which is what it is out there in the world, perhaps as markings on a piece of paper or something like that. I don't think there's a distinction to be drawn between more basic and less basic digital formats, but I get the sense of what he means there. He means data as a series of ones and zeros, because that's the most basic data format we can get. But ultimately, all data becomes a series of ones and zeros. For now, right? I mean, in the future, we might be working with quantum computers and things aren't so simple anymore. But for now, it's all ones and zeros. So maybe we'll just think of data as the ones and zeros that are presented for analysis by an AI or analytical system. If we just say it like that, we're actually pulling out and pulling away some of our presuppositions as to what data must be. It's just ones and zeros. That's what it is. And then we might call it a number. We might call it a graph. We might call it a fact. But to the computer, it's just ones and zeros. And we're feeding it into the computer. So we entered the age of big data, maybe 10, 20 years ago. Chris Anderson, writing in 2008, well after the demise of Wired as an actually useful and cyberpunk publication, wrote about basically data and the end of theory, writing, quote, "This is a world in which massive amounts of data and applied mathematics replace every other tool that might be brought to bear. Out with every theory of human behavior, from linguistics to sociology. Forget taxonomy, ontology, and psychology." Now, that's pretty extreme, right? Because basically what he's saying is it's all ones and zeros. But I think it's too extreme because, in addition to computers, we have to have humans somehow interacting with this system. And humans don't work well with ones and zeros. I mean, we sort of do in some limited cases, But we've developed things like language and art and music and the rest over time to communicate ideas and feelings and thoughts and sentiments in a way that is more analog than ones and zeros. So there's always going to have to be this process of interpretation. I'm using that word kind of in a technical sense and kind of in a loose sense. Maybe I should say translation between the ones and zeros and then the kinds of noises and scribblings that humans make or have in their thoughts. Certainly, Anderson's statement met with some resistance, and most immediately by people like Dana Boyd and Kate Crawford. Dana Boyd was very active in the early days of social media and became a critic of social media early on. And so it's natural that she and Crawford would also be a critic of Anderson's article. And they posed a set of what they called critical questions for big data. They asked, would it lead to better tools, services, and public goods, or would it lead to privacy incursions and invasive marketing? They asked whether it would help us understand online communities and political movements better, or instead would it be used to track protesters and suppress speech? Would it, they asked, transform how we study human communication and culture? Or instead, would it narrow the palette of research options and alter what research means? Well, obviously, we've seen in the 10 years since a bit of both for all of these questions. So, I mean, there were kind of false dilemmas. We got better tools and services and public goods. We're using one right now. But we also got privacy incursions and invasive marketing. Similarly with the rest. So it never was an either-or question to begin with. And that's important because we understand that data, and especially big data, actually is changing all the things that Chris Anderson said that it would. But it's eliminating none of the things that he said it would eliminate. And that creates a lot of tensions. And it creates a lot of disagreements in what the data is and how the data should be used. Because let's go back. This is a course about ethics, right? And someone somewhere thinks that every one of the things on this page is good. Someone thinks the privacy incursions are good. Someone thinks the marketing is good, or tracking protesters, or narrowing the palette of research options. They think it's good that we do this. Clearly, Boyd and Crawford think it's bad, just in the way they phrase these questions. But really, that determination is itself a subjective question, and not really answered by the data at all. They approached data then as big data as a cultural, technological, and scholarly phenomenon that rests on the interplay of technology, analysis, and what they called mythology. Now, the technological aspect we understand pretty well. The technological aspect might be sensors and tools, input devices like this keyboard, or like the camera that I'm recording this video on, maybe my phone. Technology would also include the processing of the data, the storage of the data, etc. Pretty much everything on the left-hand side of this diagram. The analysis part, and I'll be talking about that throughout these presentations, is the work that we do to make the data useful to us. As I said, it comes to us in the form of ones and zeros. We can't work with that as humans. Not really. So there needs to be some kind of mechanism to make this data work for us. We'll classify all of that under analysis. And then third is the mythology, and I've decided to quote that in this box here. The widespread belief that large data sets offer a higher form of intelligence and knowledge that can generate insights that were previously impossible with the aura of truth, objectivity, and accuracy. Now, there's quite a bit to unpack in that, and I think it's quite unfair of them to say mythology. There's some loaded terminology, for example, higher form of intelligence or aura of truth. Let's dispense with that. I don't think the proponents of big data are thinking in those terms. But they are thinking, and I agree with them, that big data can generate insights that were previously impossible. It can draw, for example, kinds of distinctions between populations that we couldn't draw because these distinctions are based on analyzing 50,000 characteristics instead of the usual 10 or 12 that humans use. There's also an aspect of truth and accuracy that's provided by big data. For example, when we use big data to do automated marking of essays, and I don't have it on the slide here, but there's a paper out there that says that the results of the AI generated marking were more consistent than the results of marking done by traditional professors or instructors. Now, that in a sense is more accurate. Or maybe it's more precise. Maybe the AI is clustering, but in the wrong place. That's certainly possible. But it's doing something that we weren't able to do before, for sure. And it's doing it in a way that at least appears more objective and more accurate. Now, there are ways in which it won't be, and we'll talk about that. But it doesn't follow that simply by stating this as a mythology that these things aren't actually properties of big data. Now, of course, they have a whole paper in which they're making these criticisms, and I do urge you to go read it. But I don't think we should be dismissive right off the top. I think that would be a mistake. There is a discipline that has developed from that paper and similar observations called critical data studies, and was most notably launched by Craig Dalton and Jim Thatcher about 8 years ago. And they launched it, they're looking at it from the perspective of geography and as geographers. But they launched it in the form of what they called 7 provocations. The first provocation is situating big data in time and space. So, and again, it's just a bunch of ones and zeros, but those ones and zeros come from specific times and specific places, and we need to recognize and realize that. Second provocation, technology is never as neutral as it appears. We've talked about this already in this course. Any technology could be opinionated technology. It might be designed for a certain purpose. It might be something that enables us to do new things that we weren't able to do before. It might be something that leads us to see things from a different perspective, like the telescope or the microscope. Big data, they write, does not determine social forms. The data doesn't tell us how society is organized. It does not follow from the fact that data reports an organization, say, of society, that that organization is actually in society. Data, they say, is never raw. We'll touch again on that later on in these presentations. Even though the data is nothing more than ones and zeros coming in, there are ways in which we have selected and organized those ones and zeros. They don't just magically appear out of the ether. So it's not raw in the sense that it's not, not altered or created in some way. They also said big isn't everything. And I remember a while back there's sort of a counter movement of small versus big. There was also a counter movement of slow versus fast, because big data sometimes makes you think of fast data as well. And it's true, big isn't everything. A course, for example, is one thing when it's really big and has 150,000 people in it, but it's not necessarily better or more informative, etc. They brought in the idea of counter data, and then finally they asked, what is our practice? What is the theoretical basis behind which we plan and deploy our work, our AI or analytics engines, using big data? And these are interesting questions, and obviously there's a perspective and a point of view to them. And I want to, again, draw out this distinction that Anderson raises, because we really do have two very different points of view of the world here. The one view of the world is what we'll call, quote unquote, data driven. Now, given we're recognizing all of these provocations, nonetheless, the idea is that the data is what we are studying, and the data is enough for us to study. Against that is what we might call a theoretical perspective. And, this includes critical theory, but it also includes educational theory, pretty much anything you call theory, right? And there was that whole movement that created theory. And that movement, in a sense, argues that, and I'm caricaturing it here a bit, but in a sense argues that the theory comes first. You pick your theory based on various considerations, and then you use that as a quote-unquote lens to look at the data. So you see the data through the perspective of the theory, or you see the world through the perspective of the theory. I think these are very different approaches. And I'll be honest, I fall more into the first than I do in the second. I've never been a lover of the theory-based approaches to anything. And to me, it often feels like pulling a theory out of the air and then using that doesn't seem like the right way to approach it. But then again, I would say that because, I'm more interested in the data than the theory. But we have to recognize that you can't just work with the data without any theory. And you can't just do the theory without any data. The data has to be theorized in some way, otherwise it's ones and zeros, and we just can't handle that. But the theory has to, as Heidegger would say, save the phenomena. It has to respond to, and in some important way, depend on the phenomena. It can't just be right or wrong independently of what the data says. So we need to keep these two tensions in mind as we talk about how we work with data and what the ethics of working with data happen to be. The context of critical data studies is the work that we're doing using data in order to perform analytics or artificial intelligence. So CDS, Critical Data Studies, forces us to ask questions about how we define the data, how we justify not using some data, or maybe we've just not considered some data, how the data are produced, how the data are conceptualized or organized or classified. We'll talk about that. And then the actual practice of how we'll employ the data. We've got on the right-hand side, and that's from Paul Prinsloo. On the right-hand side, we have this data maturity model of the different stages of things that we do with data. So first of all, defining it, then protecting the data. I don't know why that's a stage, but it's there. Understanding the data using data analytics tools and business intelligence, or BI. Activating the data, in other words, beginning to use the data in some way, such as creating custom audiences or personalization, etc. Optimizing the experience, for example, cross-channel journeys, and then using it to predict, using prediction models, using data to predict or anticipate customer behaviors, to serve them better. The data sources, well, this is kind of a messy slide because, there are different ways we could talk about data sources. Certainly in the field of learning analytics, to a large degree, we're looking at data from learning management systems, or LMSs, and a couple of references there. And these could be divided into two types of statistics. Engagement statistics, like, how often did you log on, how often did you review a video, and then performance statistics. How well did you do on a test, for example, or what grade would the system give your short text response. Another data source might be student interactions and discussion forum posts. And that, of course, would include memes, videos, photographs, etc. that they may have uploaded and shared with each other. But the data sources are not limited to educational tools or the educational context, and they could include social media and sources from outside that learning context. Twitter, Facebook, blog posts. If it's sufficiently invasive, it could log the websites you've read. It could log even the books you've borrowed from a library or purchased from a store. If it's really, really invasive, it tracks you around the house and watches you do hobbies. We haven't reached that point yet, but I'm sure there are people out there who would like to. And then of particular importance is just from the perspective of care and responsibility is data resulting from active intervention. A lot of analytics is treated just as though it's the exhaust from the LMS that we're analyzing. But in fact, a lot of data is produced when we actually experiment with subjects. It might be a minimal intervention with a subject, like giving them a survey, or it might be sorting them into A/B groups to do usability testing, or it might even be things like tricking them by using an AI tutor on them and seeing if they detect whether or not it's the tutor. If we go beyond the field of learning and development into something like, say, medicine, it might actually involve invasive probes, cutting open somebody to do a biopsy, stuff like that. So the interventions can be very significant. And then, of course, there's a range of studies from psychology where they've done interventions with groups. The sources of data are significantly influenced by the instruments that are used to collect the data. And by instruments here, we could think of it as very broadly, so that a survey is an instrument, a suggestion box is an instrument, but so is a sensor, a microscope, a telescope, etc. And reading Robert John Ackerman from, I guess, about 40 years ago now, you see that these instruments very much determine the nature of the data and the sources of the data. For example, if we have a motion detector in our house, by its very nature, it is going to detect only motion, and it is not going to detect, for example, the color of whatever is moving, or whether it is furry and small, or big and non-furry, etc., right? And this can lead you to draw conclusions that leave out important aspects of the environment that you're describing. Your tool might be limited in terms of range. For example, it might scan for only certain frequencies in sound, only certain colors in photography. It might have a coarse resolution or a fine resolution, so on and so forth. And it's interesting how the tools themselves, in an important way, define what we think we're measuring. And think, for example, of a thermometer. Degrees didn't exist until we developed a thermometer to measure degrees. Before we have a thermometer, there's no real sense to be made of the temperature of the air. If anything, temperature would be completely subjective and would include not just the plain air temperature, but the humidity, the effect of the wind, even perhaps our mood, how fatigued we are, how much we've sweated. I don't know what the past tense of sweated is. Sweated recently, etc. We try to even correct for that now. But there was a time when all we thought temperature was is whatever that reading was on a thermometer. And it sort of makes you think now, what else are we missing from temperature? So there's very much a sense in which our picture of the world determines what our data sources are. But conversely, our data sources very often determine what our picture of the world is. And it's something that we need to keep in mind. So that's the end of this presentation on data. And I'll stop here and we'll move on to the next presentation. Well, for me, it'll be just a couple moments. For you, it'll be as long as you want. So that's it for now. Thank you. I'm Stephen Downs.